So what's up guys, let's move on with projectiles. And we had normally discussed about the equation of projectile, the range of projectile, height, the maximum height reached by the projectile and time taken by the projectile. So these were the main things that we have discussed, and these were the basic concepts of projectile with the mathematical definitions of projectile. Now let's go further into the analysis of projectiles, where we would discuss that what type of projectiles can happen and what were the conditions of different type of projectiles. Now we have a simple projectile here in which we have seen an everyday action, and this projectile is like a normal parabola, a throwing of a ball, a kicking of a football, or something like that. So this is a normal projectile in which the direction of projectile is like this. Now if we look at the different formulas that we here have, it is easily seen that if I draw an arrow here, if I draw an arrow tangent to this side, then this is the velocity vector for us. So I can say that this is the velocity vector, right? This is the velocity vector, and it has some angle theta with the horizontal. So if I draw the horizontal, then this is the angle theta we have. Okay. Now I can easily say that by varying theta, I can have different type of projectiles here. So what we have here, we write the formula specially for the time taken and for the range. So for time taken we have 2v sine theta by g, and for the range we have v square sine of 2 theta by g. Now let us vary theta from 0 equal to 90 degree. So as theta is 0, so what we have here is theta is 0 degrees. Therefore at theta equal to 0 degrees, the time taken will be 0, right? So if you put theta equal to 0, the time taken will be 0, and the range will also be equal to 0. So at theta equal to 0 degree, we are having the range equal to 0, time equal to 0. Also the maximum height reached will also be equal to 0, right? But there is a small misconception in that. If you look at the physics here, what we are actually discussing is that theta equal to 0 means the velocity vector is parallel to the horizontal. So let us suppose that the ball is here, and what actually is happening is that we are like throwing the ball in this direction. Now we are considering the fact that there is no friction acting, no air resistance is acting, right? So when there is no friction or air resistance acting, the only force that is acting in this ball is the force of the weight, which is normal to the pathway. So there is no force acting on it, and also because there is a ground here, right? Now there is a ground here, I can say that there is a normal reaction acting. Now this normal reaction is not taken into consideration when we are having a projectile motion. Okay, so we can say that this will move straight in this direction without any uh, without any restriction. So in our physical conscience, it should tell us that the range should be infinity because there is no friction acting, so there is no force resisting the velocity vector, right? So the range here should be approaching infinity, the time also should be approaching infinity, and the height equal to 0, right? But why is the equation telling us t equal to 0 and r equal to 0? This is because it is not taking into consideration the normal reaction acting here. Because we are considering a pathway above the in air in which the air resistance, where there is no normal reaction, where there is no air resistance, and where also there is no friction. Therefore it will happen like that. So there is a very absurd kind of a case which is normally not taken into consideration. But in case the consideration comes out, there is a projectile in which the angle is theta equals 0 degree, it is important that you apply a physical conscience rather than mathematical notations. So if you apply a physical conscience, you will understand that the range is infinity, that is, it will never end. It is an endless path, and the time also taken infinity, because if there is an infinite path and the velocity is finite, the time has to be taken by infinity. But the height taken is always rightly given by the formula, and thus it is equal to 0. Now let us move on to theta at the extreme case, that is theta equal to 90 degree. Therefore at theta equal to 90 degree, we'll have certain important points. So what we have is sin theta equal to 1, cos theta equal to 0. Right. So we'll find that t equal to 2v sin theta by g. So it will be 2v sine of 90 degree by g. Okay. And so this will be equal to 2v by g. Okay. And then we have the range. The range will be is v square sine of 2 theta by g, and we know that 2 theta is 180 degree, so sine of 180 degree will be 0, therefore the range is 0, right? And then we have the height. The height is u square sine square or v square sine square theta by 2g, right? It is u square v square by 2g. So when we put 90 degree will be 1, so the height will be equal to 2 u square by 2g. Now what is actually happening in the physical world is, let's say there is a ball, the ball is here, and the ball is being thrown 90 degree, means the velocity vector is perpendicular to the horizontal and it is being thrown in this direction. So what actually it is happening is the ball is thrown in the upward direction and it is coming down to you. So we can easily see that if we take the range it is not moving in direction, neither it is moving in this direction. Okay, so these two are cancelled out. So in all, we can say that it is only moving in the vertical direction, therefore the horizontal range is equal to 0. So this thing here is right. Now let us assume the time. So when we have these kind of formula, we can also apply it in one dimensional motion. Now because the theta is, there is no theta, the theta is 90 degree with the horizontal and the whole velocity is in the perpendicular direction, then the vertical component is equal to v. Okay, so we can easily apply d is equal to half at square plus ut, right? Now d here we have equal to 0, therefore now we have d equal to 0. This implies that this is equal to ut, that is v into the time t, minus, because the g is in the downward direction and we are taking upward direction and positive, minus g into t square. From here we again have t is equal to 2v by g, so which is also given by the projectile formula. And then we have the height taken. The height will be half the time that is taken, because it is symmetrical situation, therefore only half of time will be taken to reach the upward point. Therefore the height taken will be half into it will be ut plus half at square. This time the t will be v square by g, therefore u is v by g into v by g plus half minus g times v square by g square. From here we will get this is equal to v square by 2g, and that is what we have from the equation. Therefore this is also a type of projectile motion. Now there will be a specific case. There will be a specific case in which the range will be maximum. Now at height equal to maximum, the height is maximum when sin theta is equal to 1, and at sin theta is equal to 1 is theta is equal to 90 degree. But there will be a case in which the range will be maximum. So like we have a ball here and it is going like this. So there will be a range that will be maximum, the maximum range. And this range maximum can be easily found out if sin 2 theta is equal to 1. So what actually is happening here is, because when range is maximum, we know the range is equal to v square sine of 2 theta by g. Therefore this thing here has to be equal to 1, and that is only possible if 2 theta is equal to 90 degree in the range theta equal to 0 to 90 degree. Then from here we have theta equal to 45 degree. Therefore when we throw the ball at an angle of 45 degree, so we have this ball and we are throwing it like this, right? And when this angle here it is equal to theta is equal to 45 degree, then the range, this thing is maximum. So at theta equal to 45 degree, we can throw the ball to the higher distance. Therefore the bowlers, when they play cricket and they are standing at the boundary, then they try to throw the ball nearest to 45 degrees so that the ball reaches by the maximum range and it can reach the bowler. So whenever we want to throw the ball to our highest height, we try to throw it directly upwards. When we try to throw the ball in the maximum time, we also throw the ball upwards. If we want to throw the ball in the shortest time, then sine theta has to be 0. But when sine theta equal to 0, then theta is equal to 0. But in that case, there is an absurd condition that theta is infinity. So therefore, we can take sine theta approaches 0 rather than sine theta equal to 0. And when we need to throw ball at the maximum range, that is the maximum horizontal distance, then we have to throw it at theta equal to 45 degree.